Are you ready to unravel the mysteries of artificial intelligence? Brace yourself as we dive deeper into this intriguing realm of technology. We'll break down complex AI concepts into easily digestible knowledge bites. Our journey began with basics of AI, and today, we've ventured into everything from machine learning algorithms to artificial neural networks. Our mission isn't complex, making AI accessible to everyone, irrespective of their background or previous experience. Everyone deserves to understand the technology that's revolutionizing our world. Today, we're taking you on an exhilarating exploration of deep learning. So buckle up, it's time to voyage into the neural networks of AI. Imagine teaching a machine to learn like a human brain. That, in essence, is deep learning. Let's dive into the fascinating world of deep learning. At its core, deep learning is a subset of artificial intelligence, but it's also a step beyond. It's like the bright, ambitious younger sibling in the AI family, eager to outshine its relatives. If we think of AI as the umbrella term, machine learning is one of the strong spokes supporting it. Now, deep learning is an even more specialized subset of machine learning. It's like a matryoshka doll, where AI is the outermost doll, machine learning is the next one inside, and nestled within that, you find deep learning. But what makes deep learning special? Well, deep learning models are inspired by the human brain. They use something called artificial neural networks with many layers, hence the term deep. These layers are adept at learning from vast amounts of data, much like our brain learns from every interaction, every experience. Now you might be wondering, how does deep learning do this magic? It's all about patterns. Deep learning algorithms can detect patterns in data and learn from them. Imagine teaching a child to recognize a cat. You show them several pictures of cats, and over time they start understanding what a cat looks like. That's pretty much what deep learning does, but on a much, much larger scale. So, if AI is the grand old castle of machine intelligence, machine learning is the sturdy brickwork, and deep learning, well, it's the intricate tapestry hanging on the walls, full of complex, beautiful patterns that give the castle its character. Remember, deep learning is not just a buzzword. It's a powerful tool that's changing the way we live and work, driving advancements in fields from healthcare to self-driving cars, and much more. In the realm of AI, deep learning is the sorcerer, conjuring magic from data. Picture this, a machine that can diagnose diseases with the same accuracy as a trained doctor. Welcome to the world of deep learning in medicine. Now, let's take a closer look at a real-world example. Imagine a hospital filled with patients waiting for their turn to get medical scans. The typical process is laborious and time-consuming, with a radiologist having to manually analyze each scan. But what if we could expedite this process? Enter deep learning, a subset of artificial intelligence that mimics the workings of the human brain in processing data. It's like teaching a machine to be a detective, finding patterns and making connections that humans might miss. Let's talk about a company called Zebra Medical Vision. They've developed a deep learning algorithm that can identify lung cancer by analyzing CT scans. The process starts with the algorithm being fed thousands of CT scans, both of healthy lungs and those with cancer. Over time, the algorithm learns to distinguish between the two, identifying the telltale signs of cancer. But how does it do this? Well, think of it like learning a new language. At first you might struggle with the alphabets, but as you keep practicing, you start recognizing words, then sentences, and before you know it, you're fluent. Similarly, the algorithm starts by recognizing simple shapes, then complex structures, and eventually anomalies that indicate disease. The results? They're pretty impressive. The algorithm has shown to be as accurate as a trained radiologist in detecting lung cancer, but it does so much faster. This means patients can get their results quicker, potentially leading to earlier treatment and better outcomes. But here's the kicker. Deep learning isn't here to replace doctors. Instead, it's like a high-tech assistant, enhancing their abilities and making their job more efficient. Doctors can then focus on what they do best, caring for patients. So there you have it. A glimpse into how deep learning is revolutionizing medicine, making healthcare more accurate and accessible. It's a brave new world, and we're just scratching the surface. Deep learning is not replacing doctors, but enhancing their abilities, making healthcare more accurate and accessible. How does a driverless car know when to stop, start, or swerve? The answer lies in deep learning. Imagine a car that can navigate through traffic, obey traffic signals, and avoid pedestrians all by itself. This isn't a scene from a science fiction movie, but a reality made possible by deep learning. So how does it work? Let's break it down. Deep learning is a subset of machine learning, which in turn is a branch of artificial intelligence. It's designed to mimic the human brain's ability to learn and make decisions. It uses layered structures of algorithms called neural networks, which are inspired by the human brain's structure and function. Now, let's bring it back to autonomous vehicles. These vehicles are loaded with a plethora of sensors, cameras, and radars, which constantly gather data about the vehicle's surroundings. This data might include the positions of nearby vehicles, the speed at which they're moving, the condition of the road, and even the presence of pedestrians or cyclists. This is where deep learning comes into play. The deep learning algorithms process this raw data, identify patterns, and make predictions, just like our brain does. For instance, if the sensors detect a pedestrian on the road, the deep learning system will identify it and instruct the vehicle to slow down or stop. But it doesn't stop there. As the car continues to drive and gather more data, the deep learning system keeps learning and improving, becoming better at predicting and reacting to different scenarios. This continuous learning is what makes deep learning so powerful and essential to autonomous vehicles. In a nutshell, deep learning allows autonomous vehicles to understand and interact with the world around them. It's like having an invisible chauffeur who's always learning, always alert, and never tired. Remember, while this technology is impressive, it's still in its early stages. There are many challenges to overcome before we see a world where every car on the road is autonomous. But one thing is certain: deep learning is at the heart of this revolution, driving us towards a future where our cars are not just machines, but intelligent companions. Deep learning is the invisible chauffeur in every self-driving car, ensuring a safe and smooth ride. Every technology has its Achilles heel, and deep learning is no exception. This potent AI tool, capable of diagnosing diseases and driving autonomous vehicles, has a few chinks in its armor. Let's delve into the challenges and limitations of deep learning. Firstly, deep learning requires a colossal amount of data to function effectively. It's like a newborn baby, needing to learn everything from scratch, but with a voracious appetite for data. For example, a deep learning model trained to identify dogs would need thousands of dog images to reach a satisfactory level of accuracy. Secondly, there's the issue of computational power. Training these models is akin to a high-stakes poker game, where the chips are processing power and memory. It requires high-end hardware, and even then, it can take days, weeks, or even months for a model to learn adequately. Next on the list is interpretability, or rather, the lack thereof. Deep learning models are often referred to as black boxes. That's because while they can make accurate predictions, how they arrive at these conclusions is often a mystery. This can be problematic, especially in fields like healthcare, where understanding the why behind a diagnosis can be just as important as the diagnosis itself. And let's not forget, deep learning models can be tricked. This phenomenon, known as adversarial attacks, can lead to some strange and potentially dangerous outcomes. Imagine a self-driving car misidentifying a stop sign because of a slight alteration to the sign's appearance. That could lead to some hair-raising situations on the road. Finally, there's the ethical dimension. Deep learning models learn from the data they're fed. If that data is biased, the model's outcomes will likely be biased too. This can perpetuate harmful stereotypes and inequalities, making the ethical use of deep learning a challenge in and of itself. Understanding these limitations helps us appreciate the complexities of deep learning and strive for better solutions. So while deep learning has its limitations, it's an evolving field, and these challenges are just stepping stones to more advanced and reliable AI technologies. If deep learning were a movie, we'd still be watching the trailers. The main event is yet to come. Just imagine the possibilities that the future holds for deep learning. It's like a treasure chest of discoveries, waiting to be unlocked. The potential applications are virtually limitless. Think of a world where deep learning could predict natural disasters before they strike, saving countless lives. Imagine if it could decipher the mysteries of our universe, finding patterns in cosmic data that the human eye could never detect. Picture a future where deep learning could revolutionize the field of medicine. It could predict diseases before they occur, tailor treatments to individual patients, and even assist surgeons in complex operations. Consider the potential in the realm of climate science. Deep learning could help us understand the intricate dynamics of our planet's climate, enabling us to make accurate predictions and devise effective strategies to combat climate change. Envision a time when deep learning could enhance our everyday lives in ways we can't even fathom right now. It could streamline our daily tasks, personalize our experiences, and make our interactions with technology more intuitive and seamless. It's important to remember that these are not just fanciful dreams. Researchers and innovators around the world are tirelessly working to turn these visions into reality. They are pushing the boundaries of what's possible, constantly striving to unlock the full potential of deep learning. However, it's also vital to understand that the road to these advancements is not without its challenges. As with any pioneering technology, there will be obstacles to overcome, ethical considerations to address, and societal implications to navigate. But the promise of what lies ahead is too great to ignore. The potential benefits of deep learning are transformative, and the possibilities are as diverse as they are exciting. The future of deep learning is as vast as the universe itself, full of potential and yet to be explored. Demystifying deep learning is like unveiling a cosmic mystery, one that is shaping our world in incredible ways. Deep learning, the bright star of the artificial intelligence constellation, is not only an academic pursuit, it is a tool, a lens through which we can better understand and interact with the world around us. Let's take a moment to reflect on our journey through this vast universe. We started by defining deep learning, this intricate network of artificial neurons, capable of processing and learning from vast amounts of data. From there, we ventured into the real world, exploring how deep learning is used in medicine, aiding in diagnostics and treatment plans. Next, we took a ride in autonomous vehicles, understanding how deep learning helps these machines navigate our world safely and efficiently. We also took a moment to acknowledge the challenges and limitations of deep learning. It's not a perfect system, and it's important to remember that. Challenges such as understanding the why behind decisions, the need for large amounts of data, and the risk of bias in models are all things we need to be aware of and work towards solving. Looking ahead, the future of deep learning shines brighter than ever. This technology will continue to evolve, become more efficient, and find new applications, changing the way we live and work. It's an exciting time to be a part of this journey, and we hope you're as thrilled as we are to see what's next. In the grand scheme of things, deep learning is just one small part of the AI universe, but understanding it brings us one step closer to comprehending the full expanse of this cosmic marvel. So, keep asking questions, keep learning, and keep pushing the boundaries of what's possible. Thank you for joining us on this stellar journey. Stay curious, keep exploring, and remember, the universe of AI is within your reach. Farewell from Astronova.